Hello students, welcome to this class. In this class we are going to understand the concept of uniform and non-uniform motion. In the previous classes we have studied about distance, displacement, speed and velocity, and we also studied the different types of speeds and different types of velocities. Now the next important topic which we have to learn is acceleration. In order to understand acceleration, we must know what is uniform motion and non-uniform motion. So this class is specially meant to understand uniform and non-uniform motion. We are going to consider some activities, different activities. I'm not going to show you any activities, but we are going to discuss about the activities in order to understand the concept behind uniform motion and non-uniform motion. So I'm going to consider 5 activities. Okay. So let us see the first activity. Activity 1. Activity 1. So in this activity 1, we are going to understand the uniform motion. Uniform motion. So let us consider a cyclist. Let us consider a cyclist moving on a straight road. Cyclist moving on a straight road. Moving on a straight road. Now this is very important. In which that is the path. How is the path? The path is a straight road. So it's a straight road. So right now the cyclist is moving. Let me say. So it's moving like this. So in 1 second. Okay, so in 1 second, let me say he's traveled a distance of 2 meters. And in another 1 second, let me say he has traveled another 2 meters. Okay, and in another 1 second, let me say he has traveled a distance of 2 meters. Okay, so if you see in a tabular form, we can see that. Let me take the time here and the distance. So let me say when the time is 0 here. So this is after 1 second here. So here t is equal to 0. So let me say t is equal to after 1 second, it is 1 second, and let me say here t is equal to 2 seconds. And t is equal to 3 seconds here. Okay. So t is equal to 1 second, 2 seconds, 3 seconds and 4 seconds. So when the t is equal to 0, let me say the distance is also 0. After 1 second it is 2 meters. Okay. And after 2 seconds another 2 meters, total 4 meters, 6 meters and 8 meters. So on. So when the time, that is, suppose this is the reference point. This is the reference point. The vehicle is here, and now the time starts. After 1 second, the vehicle comes here, covering a distance of 2 meters. So after 1 second, the body has traveled a distance of 2 meters. And again after 1 second, another 2 meters. So total 4. 2 plus 2, 4. After 1 more second, that is total 6 meters. So on. Okay. Now here what is happening is that the body is covering, see the distances is covering equal distances in equal intervals of time. Okay. So let me write. If the body covers equal distances in equal intervals of time, in straight line, the body covers equal distances in equal intervals time in straight line, then the body is set to move with uniform motion. Okay, the body is said to move with uniform motion. And here you have to understand that as the body is covering equal distances and equal intervals of time in straight line, we said that the body is moving with uniform velocity. This we studied in the last class. Okay, so you have to remember, if the body is moving with uniform velocity, then the body is said to move with uniform motion. Uniform motion. And here you have to keep in mind two important things. What are the two important things satisfied is, that is the conditions we can take it as. The first condition you can understand that it is moving in a straight road. Okay, that is, we can say direction of motion. Direction of motion is constant. The direction of motion, it is in a straight line. Okay, the direction is not changing. That is the first condition. The second is, see, it is covering equal distances and equal intervals of time. So what does it means is that we can say that the speed is constant. We can say the speed is constant. Always remember, whenever the body travels in straight road, it has the same speed and same velocity. The speed and velocity will be same whenever the body travels in straight line, covering equal distance and equal intervals of time. Okay, so we can say here the second condition as the speed is constant. Speed of body is constant. Speed of body is constant. So what is uniform motion is, if the body is moving with uniform velocity, then we say that the body is moving with uniform motion. And what do we mean by uniform velocity? The body should travel in a straight line. That is, the direction of motion should be constant, and the body must cover equal distances in equal intervals of time. Now, let us, if we plot a graph, how do we get the graph? So let me draw the graph, children, here. So x-axis and y-axis. Okay, the time is taken on x-axis. So here you have the 0, 0 coordinates. This is 1 second, this is 2 seconds, this is 3 seconds, and this is 4 seconds. And let me show here, it is that is 2 meters, it is 4 meters, it is 6 meters, and 8 meters. Okay, so right. So the time is 0, the distance is also 0, that is here. So we get the point here. Now for 1 second, with 1 second, what is the distance traveled? 2 meters. So here. And coming to the 2 seconds, the distance traveled 4 meters. So like this, if you see, you can see that you are going to get a, if you join all the points, we are going to get a straight line. So how is the graph for uniform motion? So the graph, how is the graph? So it's a straight line, or you can say linear graph. It's a linear graph. So once again, let us try to understand uniform motion. The basic important condition, two conditions here. That is, the direction of motion should be constant and the speed of the body is constant. If these two things are constant, we say that the body is moving with uniform velocity. If the body moves with uniform velocity, the body will travel with uniform motion. In case of uniform motion, how do you get the graph? It's a linear graph. That is, we get a straight line. Okay, children, so this was the first activity. Now we are going for the second activity, and the second, third, fourth and fifth, this last four activities we are going to discuss about the non-uniform motion. Okay, so I hope you have understood uniform motion. Now there are some changes I would like to make it into non-uniform. Okay, so let me write here activity 2. So now we are going to see activity 2. Activity 2, and we are going to see about non-uniform motion. Now in case of non-uniform motion, I am considering a cyclist moving on a straight road. Okay, So cyclist is moving like this, but the distances which the body covers are different. So let me say here it is moving with 3 meters and here it's moving with 4 meters. Okay, so I have to change these values also. So for first second covered 2 meters. Now after second it has covered 5 meters. 3 plus 2. Okay, and after 3 seconds, okay, 4, 9 meters. Okay, so and so on the vehicle. So here the vehicle, the cyclist is moving with, you can see here 2 meters in first second, in another second 3 meters. That is, the distance is changed, the distance is increasing, and next it has covered 4 meters. Okay, so what kind of changes we bring here? Only one thing. If the body covers unequal distances in equal intervals of time in straight line, the body is said to move with non-uniform motion. Non-uniform motion. So what are the conditions here? That is, or what are the observations? What is the observation? So whatever the direction of motion, is the direction of motion changing or is it same? See, the direction of motion, as it is moving on a straight road, the direction of motion is same. Direction of motion is constant. Uniform motion also it was constant. Here also it is constant. But whatever the speed, previously the speed was constant. Here the speed of the body is not constant. Okay. So speed of body is not constant. It is variable. Since the speed of the body is not constant here, we say that it is moving with non-uniform motion. Okay, and let me see the graph. How do you get the graph? X-axis and y-axis. Okay, so 1 second, 2 seconds, 3 seconds and 4 seconds. 2 meters, 4 meters, 6 meters, 8 meters. So first initially the position is here, and after 1 second it is 2 meters. That is, you get the point here, and 2 seconds it is 5 meters, so it is here. It's here. Okay, so this may be 1 meter. Okay, this is 2 and this is 3 meters, and this is 5 and this is 7. I hope you are able to follow, right? Now after 3 seconds it is 9 meters. 9 meters is here. Okay, if I join, see how is that you are getting? Is it a straight line? No, it's not a straight line, it's not a linear graph. You are getting a non-linear graph. So let me write the graph. How do you get the graph? That is, here you have the time on the x-axis. On the y-axis you are taking the distance. So non-linear graph. Non-linear graph. So in case of non-uniform motion, what kind of graph you are getting? Non-linear graph. Okay, so let me define the non-uniform motion once again. If the body covers unequal distances in equal intervals of time in straight line, then the body is said to move with non-uniform motion. And what kind of observations we have made here? The direction of motion is constant and the speed of the body is not constant. Okay, it is variable. Since the speed is changing, we say that the body is moving with non-uniform motion. Okay, so in all the, now we are going to see other three activities also. In the three activities are related to non-uniform motion. Okay, so you have to concentrate on these two things particularly. How is the direction of motion and how is the speed of the body. So if you concentrate on these things, then we'll very clearly understand what is uniform and non-uniform motion. Okay children, now we'll go for the third activity. In this third activity also we are going to see that it is a non-uniform motion, but the example is different. So, in the activity 3 children, we are going to take a inclined plane. So, how is the inclined plane? Generally, suppose if you look at the surfaces, if the above surface is moving, I'm lifting like this, it is making some angle. So, there is some angle here. Okay. And if suppose the angle is 0, then we say it's a flat surface. But if it is making some angle, if some angle starts, then we say there is some angle of inclination. So that is called the inclined planes. Okay, so inclined plane is something like this. Okay, so in the inclined plane is, generally it is like this. This is the inclined plane. And this is the angle of inclination. It may be 30 degrees, it may be 40 degrees, it may be 10 degrees also. Okay, right. Now, if I take an inclined plane, place like this, and take a ball and put the ball here, on the top surface and leave the ball, then what happens is that the ball rolls. Okay, it rolls and falls like this. Okay. Now, as the ball rolls, what about the speed of the ball? The speed of the ball will increase or decrease, or is it constant? Okay, when you do this activity, and we can also understand that when you drop the ball, what happens is that the speed of the ball increases. The speed of the ball increases. We can understand, let me say t is equal to 0 here. That is when I put the ball here, I am going to start the time. Okay, and when I drop here, when the ball reaches here, when the ball comes here, let me say that is t is equal to 1 second. And let me say it is 10 centimeters here. It is 10 centimeters. It has come 10 centimeters. It has passed 10 centimeters. Now next, when after 2 seconds, t is equal to 2 seconds, let me say it is 15 centimeters. 10 centimeters, 15 centimeters. Okay, that is what is happening as the time proceeds. As the time proceeds, we can see that the distance is increasing. So we can say that the speed of the body is increasing. The speed of the body is not constant. Okay. If you take the opposite case, that if you take the inclined plane and suppose you throw the ball in upward direction. You throw the ball upward. If you want to throw it upward, you have to exert one force here. But apply one force. When you apply a force here, what happens is that, so here what happens for the first second, okay, t is equal to 0 and t is equal to 1 second. So here what happens in the first second, it may be 15 meters. And next second, that is t is equal to 2 seconds, it may be 10, here we are taking centimeters, 15 centimeters, here 10 centimeters. Okay. So here, as the time proceeds, what is happening is that the distance is increasing. But here, if you consider when you're throwing the ball upwards, the distance in the beginning is more. As the time proceeds, the distance will decrease. So we can say that here, the speed is increasing. You can say here, this example, the speed is decreasing. In both the cases, what is happening to speed is increasing or decreasing. So we say the speed changes. The speed is not constant. Okay. And what about the direction? The direction of motion, as the body is going in straight line. Okay, here the body is going in one single direction. So the direction of motion is like this. Direction of motion. Direction of motion. We'll observe that the direction of motion is not changing here as well as here. What is changing here and here? Only speed is changing. So actually this activity 3 and activity 2 both comes under non-uniform motion. Okay, so the same is applied if the body covers unequal distances in equal intervals of time in straight line. The body is said to move with non-uniform motion. And what are the observations here as well as here? The direction of motion is constant. Here it is moving in one single direction. Here also it is moving in one single direction. But what about the speed? The speed is, here the speed is, I'll say speed is increasing. The speed is increasing. And here the speed is decreasing. You can take other example for this. You can take a ball, okay, and you can throw upwards. As you throw upwards, okay, that example and this example both are same. As you throw upwards, what happens is that the distances in the initial stage, the distances will be more, and as the time proceeds, what happens is that the distance which it covers will be decreasing. Okay, so we can say that as the ball is going upwards, the speed will decrease. Okay, and the ball is going in a straight direction. And when the ball comes back, this is the example. Okay, as the ball comes back, again what happens is that the distance covered will be less, but as the time proceeds, what happens, the distance covered will be more. So the speed increases. So when you take a ball and throw upwards, the speed decreases. Okay, the speed decreases and becomes 0 on the top, at the topmost point, and then again as the ball is coming back, what happens, the speed increases, right? So this is the other example, same as the activity 3. Okay, so in this, what is the main thing is that the direction of motion is constant, but the speed of the body is changing. So this kind of motion is also called as non-uniform motion. Okay, children, now we are going to see activity 4. So activity 4 also comes under non-uniform motion. So here we are going to take a stone. We are going to take a stone and tie a string to it, or a rope or a thread, you can tie it, and then what you do is you whirl it. You whirl it. And this kind of activity generally all the students will enjoy doing this, right? You can take a stone, tie a thread, and then you start whirling. Okay, now look at let me draw the path of the stone. Okay, it is circular path. So it is whirling like this. So let me say that this is a string and this is a stone. Okay, so it is making a circular motion. It is making a circular motion. Now, if you look at this diagram, suppose when the stone is here, if you leave the stone at that particular point, as it is moving, if you leave the stone at that particular point, what happens? The stone just goes in this direction. Okay, and if you leave, suppose the stone is here, if you leave the stone here, what happens? It moves in a tangential direction at that particular point. It moves in a tangential direction. Okay, if you leave here, then the body will move in this direction. Actually, what is this? This is the direction of velocity of the stone at that particular point. And at this particular point, this tangents give information about the direction of velocity at this particular points. So what is the direction of velocity of the stone when the body is here? Means it is your draw a tangent. That is the direction of velocity. Okay, that is the direction of velocity. So direction of velocity, very clearly you can see here that it is changing, right? And one thing you have to assume, we have to assume that you have to rotate in such a manner that the speed is constant. So you have to assume that speed of stone is constant. Stone is constant. It's not compulsory that it should be constant. While as you are rotating, it may be, the speed may be changing. Okay. But what I say here is the condition. Here we have to maintain this condition. You have to maintain this condition. What is the condition? Assume that the speed of the stone is constant. What do you mean by the speed of the stone is constant? For every second, for 1 second, you have to see that it may move with either 2 rotations, or it is moving with 3 rotations, or it may move with, if you may whirl it very quickly, then it may move with 4 rotations also for 1 second. Okay, if you maintain that, then we say that the speed is constant. Okay, for example, if you switch on a fan, in the initial stages, the speed is increasing. Okay, it may, that is for 1 second, it may move 2 rotations. Another second, it may move 3 rotations. Another second, it may move 4 rotations, 5 rotations, 6. Like that, the speed is increasing. After some time, what happens? It rotates with uniform speed. That is, speed is constant. That is, for 1 second, it may move with 10 rotations. Another second, 10 rotations. Another second, again 10 rotations. That is, it is speed is uniform. The speed is constant. And again, when you switch off the fan, what happens is that slowly what happens, we'll see that the number of rotations will be decreasing for every 1 second. That is, the speed is decreasing. That is what I mean by saying the speed is constant. Okay, right. So here, what is the condition you have to maintain is that assume that the speed of the stone is maintained constant. Okay, and what about the direction of motion here? See, the direction of motion is changing at every point. The direction of motion is not same. Okay, in circular motion, at every point the direction of that body is changing. So here, what is the observation? The direction of motion, is it constant? No. The direction of motion is changing. Is changing, or we can say variable. Is not constant, or it's changing. Whatever the speed of the body here, the speed of the body is, let me write, speed of the body is constant. Speed of body is constant. This condition we are maintaining. Okay, the speed of body is constant and direction of motion is changing. Previously we have seen that direction of motion was constant, but speed was changing. Okay, in this example what we have observed, that the speed is constant but the direction of motion is changing. Okay, now this kind of motion is also called as a non-uniform motion. So here we may say that the body covers, we may say, equal distances in equal intervals of time, and it may not be straight line. So I am not trying to define this kind of motion. I am not going to define here. So here, what is a, so this is a definition for non-uniform motion. Okay, and here, so what is happening is that the direction is changing and the speed is constant. So this kind of motion also comes under the non-uniform motion. Okay. Okay, students, now let us see the last activity, right? So it's a 5th activity. Now, we'll take the example such as in cricket, we'll see that the fielder will take the ball and he'll throw the ball towards the wicket keeper. Then how is we are going to draw the path of the ball traveled by the cricket ball. Okay, so such kind of motion we are going to see. That is, the ground is like this. Let me say it is horizontal. Don't throw the ball along the direction, that is along the horizontal. Okay, or don't throw the ball vertically upwards. You have to throw the ball making some angle with the horizontal. That is, either you can throw like this, or you can throw in this way, or you can throw in this direction. So when you throw the ball, what happens? The ball will travel a parabolic path. Okay, so I am going to show that direction. Okay, so the ball is traveling like this. The ball travels in this direction. When you throw a ball making some angle with the horizontal, okay, it is making some angle with the horizontal, then the ball will follow this kind of path, parabolic path. Okay, now when the ball is here, and when the ball is here, so we are going to see the same thing, the direction of motion, the speed of motion. Okay, so let me say, okay, the direction of motion may be same here, the direction of motion is still here, it is same, but when it comes to this particular path, the direction of motion here is in this direction. Till here it may be this direction, and now here the direction of motion is this. The direction of motion is changing. Okay, we can observe here. And what about the speed of the body? Previously the speed of the body is constant, but coming to here, as the ball is thrown upwards, from here to here the speed decreases. The speed of the ball decreases, the speed of the ball becomes 0, and again the speed will increase. The speed will increase. Okay, so we can see here the speed of the body is again not constant, is changing. So here we can observe, children, the direction of motion is changing. We can see that the speed of the body is also changing. So this kind of examples also comes under non-uniform motion. Okay, so now let me write what are the conditions. Once again, let me summarize. In case of the uniform motion, so when do you say that the body is moving with uniform motion? When the body is traveling with uniform velocity. Okay, if body travels with uniform velocity, then the body is said to move with uniform motion. And when do you say that the body is moving with uniform velocity? Direction of motion and speed of the body. Both are constant. Direction of motion and the speed of the body, if these two things are constant, then we say that the body is traveling with uniform velocity. And when body moves with uniform velocity, we say it's moving with uniform motion. If any of these conditions are not satisfied, then we say that the body is moving with non-uniform motion. In the second example, we have seen that the direction of motion is constant, but the speed was changing. And coming to the fourth example, we have seen that the direction was changing, the speed is constant. In the last example, we can see that the direction of motion is changing as well as speed is changing. Okay, so if this kind of things happen, that is the direction changes and the speed changes, then we say that the body is moving with the non-uniform motion. The concept of uniform and non-uniform motion is very, very important in order to explain the concept of acceleration. Why? Because we say that when the body is moving with uniform motion, we say that there is no acceleration present. When the body is moving with non-uniform motion, then we say that acceleration is present. About acceleration, we are going to study more clearly in our next class.
Tell me pretty lies, look me in the face, tell me that you love me, even if it's fake.